Here are 3 separate videos that will help you fix sagging roofs, floors, and ceilings. So let's go ahead and get started with our first video. In this video, I will provide you with a few things to think about if you have a sagging roof ridge. And before we do that, let's go ahead and take a look at a house where everything is nice and straight. The walls are plumb. You can actually place a level up against the walls and everything should be vertically plumb and nice and flat. So flat walls, a nice flat sloping surface for the roof, and a house without a sagging ridge. And if we look at this house here, you can see where the outside edge of the roof is still straight. One of the most common problems with a sagging roof will be that it doesn't have any rafter ties or ceiling joist. And over time it will push the walls out on both sides of the building. It's probably not going to happen on the end because the wall itself will be holding everything together. However, that won't be the case in between the 2 outer gable walls. And something like this shouldn't require that much thought. If the building is allowed to spread apart, then you could actually see how the roof would sag over time. And again, this is the most common problem you're going to have with a sagging roof. The next problem you could have would be the same situation, except for the fact that the walls will not be bowing out in the center of the building. And if you have a situation like this where you have a sagging roof, but the perimeter walls are still plumb, then there's a good chance you have some type of structural lumber damage, maybe termites, wood rot, or the wrong lumber sizes. Instead of a 2x6, you needed a 2x8. And if you have a wood framed floor, you could have a problem with the floor also. The floor could be sagging in the center of the building. So you're going to want to focus more on lumber damage and floor damage if you have a situation like this. And even though I've suggested those, if you have any suggestions on what could be the problems for any one of these that I haven't mentioned, feel free to share them with us in the comment area. Next up, let's go ahead and take a look at a problem that you could have if the ridge is sagging, the exterior wall is sagging, and the building foundation is sagging. And of course, that's going to be your problem with this roof over here. You're going to want to focus on the building foundation. The damage could be from erosion or a foundation that wasn't built correctly or strong enough. So again, the walls could be vertically plumb in a situation like this. And this is actually a house that I drive by probably 3 times a week in our area. So again, this situation right here probably going to be foundation damage. Next up, let's go ahead and take a look at a house that has a straight or a level foundation. However, the walls are sagging and the ridge is sagging. Something like this might be a red flag for termite damage. However, you're rarely going to come across something like this where the stucco or the siding isn't buckling. And keep in mind that I have exaggerated some of these curves to provide you with an example of what something might look like. Your walls could actually be sagging about 1 inch along with a ridge. The damage might not be that noticeable to most people. However, this doesn't mean that you shouldn't try and find out what's going on, where the problem is, and if you can fix it right now to prevent it from getting worse in the future. In this video, I will be trying to help out one of our viewers and at the same time maybe helping out a few other people who are dealing with a sagging roof ridge and an older house that has 2x4 roof rafters and maybe a 1x6 ridge, and maybe you don't even have a ridge at all. And at the same time, try and give you a brief explanation of what's going on here when you might have rafter ties going across. And of course, some of you think that they're ceiling joists, and they aren't. These are rafter ties. These are meant to prevent the walls from spreading out. And this would work kind of like this. As there is weight applied to the roof rafters, maybe from snow or something else, or even just the weight of the roof itself, If you do not have the rafter ties, then the weight of the roof eventually is going to sag down, or should I say could sag down. And without the rafter ties, the walls will actually spread out. As the walls spread out, the roof rafters and the ridge will start to move down also. And now if you do have a roof that's in really bad shape, you might need to remove and replace it. However, in this video, I'm going to provide you with an idea that might work. And this is probably where I'm going to lose most of you, because I'm going to say that it might work. It won't always work. And this, of course, is going to depend upon the existing damage to the existing roof. Now, the first thing I'm going to suggest would be to use at the minimum a 4x6. And I believe the individual who emailed this question wanted to use a 4x4. And I just don't think a 4x4 is going to be enough, but I'm not going to discount the fact that we can't bolt them together or somehow connect a few of these together to make something a little stronger than a 4x4. At the same time, I need to point out that these aren't always going to be easy to get in, and you might need to cut a little more off of one side at the top so that you'll be able to shove it into this section so that you can pull it into the other side. And you can see here where this one's a little bit shorter, and yours shouldn't be that much shorter than it needs to be to get it in and then pull it over. So here you can see where we're a little bit farther away. It'd be nice to have it a little closer to maximize the length of our beam so that we can have as much of the beam sitting on top of the wall as possible. Now, as a general rule of thumb in construction, the minimum distance here is 1.5 inches. So keep that in mind, because once you pull this one over, you're going to have between 1.75 inches and 1.5 inches on each side. And of course, here you can see where the beam is shaped to the top of the roof rafters, and that'd be on both sides. And as we can see here, it's just sitting about 1.75 inches on each side. And again, if you can figure out another way to get it in, go for it to where you won't have to notch as much. But in order to slide this in on this side, you're going to have to take a little more off of this side than you will on the other side. Again, unless you can figure out another way to do it. So here we have it. It's a little bit lower than the other side. If you remember, on the other side, it was just to the bottom of the roof rafter. And of course, now that we have our first beam in, we can cut a second beam. And again, if you want to make this a 4x10 or something a little larger, or 4x4, whatever you want, these are just examples. And this is not structural engineering information, because I am not a structural engineer. So I'm just kind of throwing this out there. And if you think it will work for you, then give it a shot. And with the upper beam here, we're going to be able to cut it a little bit closer to the top of the roof rafter than we did with this one here. So here it's sticking over past a little bit, but we're really not going to have that on the other side. Now, I did put a jack along with some type of a post that we're going to be able to use to raise the ridge. But I need to point out, and hopefully this makes sense, that you're not going to be able to attach the beam to the wall framing on both sides. Now, you will be able to attach it on one side, but this other side needs to be loose, because as you raise the roof ridge, there's a good chance that you're going to be pulling the walls back in, and that's not going to happen if this beam is nailed at both ends of the framing plates. And you might even need to raise the beam a little bit. So let's say that you raise it, you got it supported, there's a lot of weight on the beams, then there's also going to be a lot of weight on the walls, and this could prevent the wall from moving. So you might need to bring the jack back over here and raise this up just a little bit, and then watch this as it pops back in, it'll snap in a little bit. And again, hopefully that makes sense. So let's go ahead and take a look at the other side where you can see where the beams are going to be shaped right on the money. Next up, let's go ahead and grab a piece of plywood. I'm using 1/2 inch plywood here. You can use larger or smaller plywood. And I'm just kind of using this to connect the two beams together to make them a little stronger. And hopefully this actually does make them a little stronger. I mean, if there's one thing I can't stand about most of the people that show you how to do repairs on YouTube, it's the fact that they don't show you what it looks like 5 or 10 years from now. I'm not trying to be deceptive, and hopefully these ideas will work, but again, No guarantee. And there are other ways to connect these beams together. I've seen it done before where they drill a hole all the way down the center and then grab a long bolt with some washers on the end and then bolt it together. And this is actually something that I've seen done before that does work. But don't get misled and don't think that by putting two 4x6 beams together that are 5.5 inches wide, providing you with a total of 11 inches, that you have a 4x12 beam. That's probably not going to happen. However, you might have something strong enough that's going to allow you to make this type of a repair and raise the ridge a little bit, or at the very least prevent it from sagging any further. So next up on the list would be to add another beam, and you would follow the same installation instructions as you did for this one. And I really can't tell you where to put them in your roof because you could move these beams over a little further in either direction. So you could space them a little closer together or further apart if you need to install a shorter or a longer beam here. And in order to get this beam in here, you might need to remove one of these rafter ties or even another rafter tie. And if you're going to put a full length beam all the way across here, then the beam might need to go in first. So again, hopefully that makes sense. And then you could always place either 1, 2, or 3 jacks on top of the beam and then start raising the ridge. And if there isn't a ridge, then you might be able to start raising the rafters. And if you have any questions about any part of the process that just doesn't make any sense or something that I might have missed, then feel free to leave those questions in the comment area or email them to me and I will answer them as soon as possible. And of course you can see that the beam is located in the center underneath the ridge and has a variety of different supports here. And you can see this one here, I kind of notched it at both ends so they could slide under there. And then that one you could always screw to the side, just like this one here where we're using a 4x4. You could just simply screw it to the side of the ridge. And of course our brace here, we're using another brace. However, this might not be necessary, just depends upon your project. Because if the roof isn't moving because it's got solid sheathing on top of it and it hasn't moved in years, and something like this probably isn't going to make that much of a difference. And again, another method here, we have a 2x4 going underneath the ridge and then something on the side, and you would just simply nail or attach this board to the ridge or even to the rafter if you didn't have a ridge, and then attach it to the other supporting block and then to the beam. Now, even though I'm not showing all of the connections everywhere, everything in this example needs to be firmly secured to the other components, and that could be done by a variety of different methods, including using straps and framing anchors and different types of building hardware. So again, just a different method. Here we have a 4x4 with a notch in it. Here we just have a 4x4 under the ridge. And here we have two 2x4s turned around. This one is shaped like this on this side here. And then this one here, we just simply use 2 of them. One that would look like this, and then we just simply flipped one of these around and then nailed it to the other side here. Another method for this would be to lower the beam and use hangers. Instead of having the beam sit on top of the other beams, you could simply hang it off of them. And again, you might need to do this for a variety of different reasons. And if this is the case, you might need to notch the rafter ties around the beam or connect them to the beam somehow. Okay, a view of the hanger, and here we're using a 4x10. However, you can use a smaller or a larger beam. And here I pulled the plywood back a little bit and connected it to the beam itself. And I actually like this idea better instead of going over the plywood. But again, if you use longer nails or screws, whatever you were using to attach the hanger to the beam, then it might be okay anyway. And here I went ahead and installed the other cross bracing so that I could have at least one connection to the gable wall here. And of course this goes all the way through and can connect with nails or screws into the gable stud, and then you could use framing hardware like we have here, attaching the brace connector to the beam, giving us a solid all the way through connection. Definitely another thing to think about, along with a view from above. And if you're looking for a little more support, you could always add a 4x4 or something larger. And I really don't see where something like this would be a problem. And in some cases, you're even going to be able to have it sit on top of the footing, at least partially. And again, just another suggestion, view of it from the other side. And of course, a 4x6, something a little larger. And of course, it is notched over the footing there and sitting directly on top of the garage slab. You can add whatever you want. You want to put some treated on here, knock yourself out. And of course, framing anchors will be handy. Anything to connect it securely, and maybe even a strap here. But you do need to make sure that everything is connected nice and tight, along with a view of how the beam is still going to be underneath the roof sheathing. And that brings us to the end of this video. Here is a helpful video for anyone who is trying to figure out how far or how bad your floor or your ceiling is sagging, with the understanding that you might not be thinking quite clearly about these measurements. For example, if everything is nice and straight, the ceiling and the floor, then you should be able to measure anywhere in this area. But more than likely, that's not going to be the case. For example, if your ceiling is sagging and you have a wood-framed floor, then there's a very good chance that your wood-framed floor will also be sagging. Now, if you have a concrete foundation, then don't assume that it's always going to be flat and level. You could have one section or multiple sections of that sagging, or even a section that is raised up from a tree that might have grown or is still growing, with the roots underneath the foundation, something raising it up in one section, and maybe even some soil erosion lowering it on the other side. Now, one of the biggest problems you're going to run into will be when they are both sagging and you're trying to get a measurement by just simply measuring off of the floor. For example, both of these floors are identical and they have a 3-inch sag in the center. And that means I'm going to have the same measurement here as I'm going to have here. Or you might have a situation where you have an 8-foot measurement here at the corner and a 7-foot 11 measurement from here to here, suggesting that you have a 1-inch sag in the ceiling, when in reality, that sag is going to be a little bit more. So hopefully that makes sense, because that's the main point I want to drive home in this video. And I think the best way to figure out if you don't have a laser level, if you do have a laser level, feel free to place it in any spot in the room and turn it on. And then just simply start measuring a few areas and writing them down on a piece of paper to figure out how much the floor or the ceiling might be sagging. However, if you don't want to purchase a laser level, you're never going to use it again, then you can go ahead and add a few more level lines all the way around the room, or a level line on this side and a level line on this side, but they need to be level. For example, if this is off a 1/2 inch in either direction, then your measurements are going to be off a little bit. And even though I'm going to be providing you with an example of how you can use a couple of straight boards and simply screw them into the wall and mess up the interior finish of the drywall or the plaster, that might not work for you. And if that's the case, just simply grab some tape, put it on the walls, make some marks, and then have one person hold the string at one end and someone else hold the string at the other end. If not, you can drive some screws into the top of it and then simply tie a string at one end and then pull it tight to create a straight line to connect to the other end. And here's the title to that video. And once you have a tight level line, you can simply measure from the bottom of the floor to the line in a variety of different sections, or you can measure from the bottom of the ceiling to the line. And if done correctly, then you should come up with some extremely accurate measurements as to whether or not your floor or your ceiling or both of them are sagging. And I will be providing you with 2 more videos, one on how to make a water level, and the other will be on how to use the water level to create accurate lines around the perimeter of your rooms or your entire house to figure out if you have other problem areas in your home that might be either raising or sinking. So make sure you stick around and watch those videos. In this video, I will be providing you with a simple and easy method to see if your floor foundation or subfloor framing is not level, out of level. And this not uncommon to have one section of the home sink into the soil through a variety of different reasons and create problems with your windows and your doors. And in some cases, even you could find yourself leveling your cabinets, TVs, stuff like that. So not a good thing. So first thing we're going to want to do is find a central location. And this isn't necessary, just something I like to do. So we will select this area right here. The next step will be to attach one end of the water level to the central location. And that can be done by a variety of different things. Tape, just tape it to the wall. Drive a screw or a nail through the edge here. Do not block either side of the water level off. It needs the air to go through to make it work. Then you'll need to make a mark somewhere. And this will be, we'll just refer to it as our main leveling mark. And I think I made this about 2 foot off the ground. Wouldn't be a bad idea to make them in equal measurements of feet, because you will be adding and subtracting measurements here. So go with a nice even number, something like 30 inches, 36 inches, something like that. I mean, 30 inches or 20 inches would be fine, or 2 feet or 3 feet, and we can go from there. So our measurement here will just say is 2 feet off of the floor, and one end of the water level is attached to the wall. And you can always have one person hold up one end of it. One person hold one end up, another person hold the other end up, and then someone else goes through and makes all of the marks. That would work just fine as long as the level does not move. If you have somebody holding it up against the wall and then you make your mark and they move it a little bit, that could be a problem with your finished measurements. Well, let's go ahead and go to the other end, make our mark, and then we will go back and then have the same mark. And I'm giving you an idea here. Let's just go back. And we can see that the mark is even with the water, but it is not even with the mark that we made here. That's because we will need to measure this distance and then transfer it to the other side, and then make our main level mark here. And wanted to show you where the water would be, kind of an idea in your water level. This is the water is being level in the tube, and of course that's where our mark is, but not our main mark. Our leveling mark, I should say, is there. Give you an idea what it looks like on the other side, and that's what it looks like there. Let's go ahead and go to another corner of the house. Again, it will be attached to the central location here, and then of course this one here we will move to the other side. Same thing, just kind of running through it again. We got our main mark, and this mark might be in a different location. These marks aren't always going to be the same, but you will simply, this is the main mark you're looking for. You'll just simply measure the distance here on all of them. So the last one was 6.5 inches. This one here could be 8 inches. It could be 3 inches, but you'll need to transfer the marks to the other side. That will be the main thing. Let's go ahead and go through the doorway here, just kind of showing you how you can go through the house. Again, this will be attached or secured somehow so that you can get your level mark and then make it on the wall framing stud. Go back to the other side and then measure the distance. So we'll pretend like this is 5 inches here. Shoot back over to the other side. 5 inches, draw a line, and now we have our main level mark again. Now this is where we can measure to see how far the floor is out of whack. So we're going to measure from our main leveling mark to the top of the floor. Top of the floor, main leveling mark. We are not going to be using these marks here. I mean, you can actually use these marks and not do this. You could just be measuring from here down to the floor, but sometimes that gets confusing. Especially if you're going to be working on the project for a couple months. It's nice to have these measurements instead of a variety of different ones. It could get a little confusing. And then we simply go back to the other side and measure the distance here and then subtract it, and that will give us our difference. Let's go ahead and do a sample measurement here. Top of the floor, which is B. The main leveling line is A. We are going to pretend like this is 24 inches. Top of the floor to our main line. Let's head over to our corner. And if this measurement is 24 inches, then your building is level. Now this is where it gets a little confusing. If this measurement is taller, let's say it's 25 inches, that means that this section is lower than the other section. If this measurement is less than 24 inches, then that means that this measurement or this section is higher than the other side where the water level is. So I hope that makes sense. Now that you have all of that stuff locked away in your brain, let's just go ahead and go over this again. This would be the first one we did. This would be the second one. You can do it throughout the entire house. You can go to the corners here of your doors, make marks on the walls, in the closets, and run these tubes all over the place. Just kind of give you an idea. Run them through the doorways. You can check all over the house, any measurement you need. Now, if you are coming to a spot, let's say that your house is 100 foot long and you bought 50 foot of tubing, you can always take and run 50 foot of tubing to the furthest point or to any point, and then run it from that area to the other points also. So once you have your main water level marks, you can move the hose if needed, and travel through other parts of the house and make your mark. So I hope this makes sense. This is how you would figure it out by going on the inside of the house. I am going to try and make a video to give you some ideas on how you would do it on the outside of the house, but this is probably going to be the best method. The outside of the house might not work because your doors and windows might not be the same height. You know, you could do it from your roof rafters, maybe measuring down, but if there are any measurements that are off a little bit, then it could create problems for you. So inside of the house, I think, is going to be better. This is actually what I would do if the walls were covered with stucco or siding, some type of finish. If you're dealing with the framing, you have all the you have the exterior of the house removed, then by all means go to the outside and do this. And this really does work good. I can't really think of, I mean, I've checked this before with builders levels, transits, and actually used water levels to check the transits to see if they were right instead of taking them in and getting recalibrated, or to see if they needed to be recalibrated. You will need to start with some clear plastic tubing, and then that will need to be filled up with water to make your water level. So let's go ahead and get a garden hose going here, and simply insert the tubing into the hose, or wrap your hand around it somehow to get the water pumping in there. And you will see all of the air bubbles flowing through there. Plenty of air bubbles. We do not want air bubbles in our water level. So after you get a little bit of water in the bucket, wouldn't be a bad idea to submerge it into the bucket. Yeah, it wouldn't be. You can grab both ends there. And you can see water coming out. But you're going to want to submerge the hose and the tubing in the water to make sure that no air is getting in. Sometimes if you just hold it together, you're going to get air sucked in there. But if you put it under the water, good chance no air is going to get in there. I'm looking for the other end of the tube right now to show you. There we go. Plenty of water. No air bubbles coming out of there. Now we can get started with our temporary setup there. If you pull out one end of the tubing, the water is going to just continue to leak back into the bucket. So stick that back in there to get the water back in it, and then grab both ends together and try and keep them even or level, however we look at it there. And then we will attach it to whatever we are going to level. And in this case, it is just going to be our temporary setup. So I have it tied on with a string. I'm going to make a mark where the water is even, or you can see it right there in the tubing. And then I'm going to mark the other side. You can see it, really get a good view of it right there where the water is. And this would be level. And when I say level, I would imagine water is level, you have to imagine. If we go around the planet Earth, it's not going to be as level as it would be just a few feet away like we're working on here. But all you need to do now is simply measure. You can see there we're about 1 3/8 inches. And again, I don't know how flat this board is. It looks like a rough sawn piece of lumber. Should have used a smooth one. There we're a little bit over 1.5 inches. Just in between 1.5 inches and 1 3/8 inches. But if you're going to level a floor, simply measure down. And you can see here we're about 32 3/4, just a little bit under 32 3/4. Measure the other side. There's the star of our show, a little hoodlum that came in the neighborhood. And then you can see here we're a little bit under 32 3/4 also. So this is even Steven. If we look at this right here, we are right on the money. And that is how a water level works. Now, what if I measured it and it was off a little bit? Let's say that the measurement on the right was 30 inches and the measurement on the left was 31 inches. This would represent a sloping direction towards the larger number. The 31-inch number would represent something deeper. And so the bigger number would represent something lower. The smaller number would represent something higher, according to the way I'm measuring it. If you change directions and you measure up, then you will have to reverse those numbers. But for down, if you're measuring down like this, then that should work out just fine. And thanks for watching. To learn more about home building and repairs, visit us at our website. Also, don't forget to subscribe for more awesome content. See you next time.